So right now, we have a photodiode in series with a 1000 ohm resistor. You saw the voltage change because I covered the photodiode. It's reverse bias. It's in series with the 1000 ohm resistor, and less light on it, the dimmer it gets. And this works out really well. We got about 0.3 volts across the 1000 ohm resistor, letting us know there's about 0.3 milliamps of current flowing. And when you got a resistor in a circuit, usually if you double the voltage, then you'll get twice the current. But there you can see we have basically the same amount of current, and I think it went up a little bit because the photodiode got a little bit warmer. It's got to dissipate a little bit more power, but in any case, it's still about 0.317 volts. Again, it's a 1000 ohm resistor. That lets us know there's about 0.3 milliamps of current flowing through the circuit. And it's set by the photodiode, not the resistor. That's the main thing to be aware of. A photodiode is basically a light-dependent current source. So now in the previous short, we had a photodiode that was reverse biased in series with the 1000 ohm resistor. We were measuring the voltage across the 1000 ohm resistor. The more light you get on a photodiode, the better it's going to conduct, the more current it's going to conduct, I should say. And the less light, the less current it's going to conduct. If you put a 1000 ohm resistor in series with it, then you're going to get 1 milliamp if there's 1 volt across the 1000 ohm resistor. If there's a 0.25 volts across the 1000 ohm resistor, then you know you got about 0.25 milliamps of current flowing through the circuit. But again, that's the photodiode setting the current. You're just measuring that. Maybe you got something else responding to the voltage, but you can't draw any current. Otherwise, that's going to throw it off completely. And there's the circuit that I measured. So we were kind of far away. But there you can see, I clipped this to the red alligator probe, and this one to the black alligator probe. We were measuring across the 1000 ohm resistor. So now in the previous short, we looked at how this setup, when it's complete, we got a reverse bias photodiode in series with a 1000 ohm resistor. We had about 0.3 volts across the resistor, but as I move things, the light kind of changes on there. But there you can see, we got about, this is milliamps, 0.3 milliamps of current, which we expect. So the current's actually flowing through the meter as well. I had to put it in series. The main thing though is, we got that 0.3 milliamps with the lamp at the dimmest setting. Again, as I bump things, it may change a little bit, and I think a little bit more current flows through the photodiode and anything in series with it when it gets warmer. But there you can see, it's still basically 0.3 milliamps, went up about 0.02 milliamps, I think, maybe 0.03 milliamps. But basically, it's the same. It's kind of a current source. So we want to open this up, make sure nothing shorts, no voltage is short across here, and get it off of measuring current. I'm going to turn it off.